Hey everyone, how's it going? I'm Paolo, your geography teacher. As always, it's an honor to have you here with me on Geo Illustrata. Today's video is a little different. Here, look, it's about map scale. My goal here is to make sure you understand this once and for all. We're going to start by talking a bit about the theory very briefly, and then we'll move on to practice and do some exercises, okay? I guarantee that if you watch until the end, you'll leave here. You'll leave this video understanding map scale and knowing how to do the calculations, okay? All right then, let's start here with the theory. Look, what is map scale? In short, map scale represents the mathematical relationship between real distances and those shown on the map. Want to see? Look, here's an example I always like to give here. Here we have Brazil. Would Brazil fit on the paper at its original size? Obviously not. So what do I do to make it fit? I reduce it. By reducing it, it will fit on the paper, right? All right, so what does the scale represent? The scale represents a reduction. Proportional reduction.
Sional.
Don't worry about the handwriting. The goal of this video is to be straightforward. So look, it's a proportional reduction. It will always show a direct relationship between the real distances and the distances in the drawing on paper. So it will always be 1 to something. What does that mean? That 1 unit on the paper will be worth some other unit in real life. Let's suppose here that the scale of this map is 1 to 500,000. 1 to 1, 2, 3, 1 to 500,000. So what does that mean? That 1 unit on the paper is worth 500,000 units in real life. In this case, which unit? It's always expressed in centimeters. 1 to 500,000. It means that 1 unit here in the drawing is worth 500,000 units in real life. What do you mean? If I take my ruler here and draw a line segment between São Paulo and Minas Gerais, and I see that this line segment is 2 centimeters, 2 centimeters, what does that mean? So it means then if 1 is worth 500,000, how much will 2 be worth? Then I do that basic proportion setup. If 1 is worth 500,000, how much will 2 be worth? It's simple. Just set up the basic proportion here. I'll get that x is worth 1 million. 3, 1, 2, 3. All right, so this distance, obviously it's hypothetical, will be worth 1 million centimeters. Right? So this is the basic principle of map scale. But for you to solve exercises, especially entrance exam ones, it's never going to be that easy, okay? Never. You know how it is. Entrance exams love to complicate things. But you'll always be dealing with 3 basic quantities, which they're going to ask you to figure out. What are they? Look, it could be D. What is D? It's the distance. Hey! Distance, huh? Centimeters, that is, the distance I measure with my ruler here on the map in centimeters, can be D, which is the real distance. Distance. Real, or it can be E. What is E? The scale. So, the exercises will always ask you for one of these basic quantities here. It could be the distance in centimeters on the drawing, the real distance on the ground in real life, or the scale, one of these 3. How do you figure that out? Let's go over this now. Let's move on to some exercises, all right? Okay, we already have our first exercise here. It's really simple. We'll go from simple to complex, all right? So this one is just to warm up. Take a look. Here are the 3 variables I said we always have to find. D, which is the real distance on the ground, D, which is the distance in centimeters on paper, and E, which is the scale. We'll always have to find one of these. I also left the conversion table here. You need to have this memorized, all right? In other words, why is that? The scale will always be presented in centimeters, okay? However, in most exercises, you'll need to convert from centimeters to kilometers, or even do the reverse, from kilometers to centimeters. Convert from kilometers to centimeters, okay? Some exercises also require conversion to meters. So you need to know how to convert, how to use these conversion units here. But we'll talk more about this during the exercises, okay? So let's go. First, the map scale shows the dimensions on the map and how they correspond to the ground, as we've already mentioned. In other words, it's an abstraction, okay? I won't waste time on this here. This is just an explanation. Second part, Considering the distance of 6 centimeters, take a look. Between the two municipalities on a map with a numerical scale of 1 to 1 million, what is the straight line distance between them? So let's identify the quantities here. What units did it give me? 6 centimeters, right? 6 centimeters represents which one here? The D, right? Which is the distance on the ground. 6 centimeters. What else did it give me? The scale, which is what? It's 1 to 1 million. So I have D and I have the scale. What does it want me to find? The real distance on the ground. So let's go. To set up the proportion, like I explained at the beginning, what is the scale of this map? 1 to 1 million. 1 to 1 million, right? So, that rule. If 1 is worth 1 million, how much? Oops. How much will 6 centimeters be worth? X. So you just have to do that cross multiplication here. X will be equal to 6 times 1 million, 6 million. 3, 1, 2, 3, 6 million. That's my result. But do I have 6 million here? No, I don't. Why? Because it wants me to convert. I found the distance in centimeters. I need to convert from centimeters to kilometers. How much is that? How many kilometers is 6 million centimeters? Take a look. Here, according to this table, I just need to move the decimal point 5 places to the left. So we're dealing with centimeters here. So how many units of measurement do we have until we get to kilometers? 1, 2, 3, 4, 5. So I just need to move the decimal point. That rule, imagine there's a decimal point here at the end. Move it 5 places to the left. So 1, 2, 3, 4, 5, I cancel all of this out. And I found my distance in kilometers. That is 60 kilometers. Okay? Basic conversion. So the answer here is letter D, 60 kilometers. Pretty easy, right? Let's make it a little more complicated now. All right, let's move to our second exercise. If you'd like to try it yourself, pause the video to check your answer. Let's begin. In this exercise, the first part here, the statement, is just filler, just padding. Let's focus on the main objective here. Look, second part, talking about a flood situation and all that, people being displaced. Look, considering that civil defense needs territorial data for planning and carrying out actions, mark the correct option with the real distance. Take a look. So, what he wants me to find out is the real distance on the ground. In kilometers here. In case it's necessary to transport the population by air, okay. Using a 9 centimeter line segment, let's see what he wants me to find. What information do I have? What are the quantities I have? Do I have the scale? Yes, I do. Look here at the scale, 1 to 250. So the scale is 250, 250,000. Okay, and what else do I have here? I have the distance on the ground, here the straight line, in centimeters. In other words, I have the D, which is 9 centimeters, right? So what I need to find is D. What is D? I don't know. That's what I need to find. Here's another trick to make this even easier. When I have D and I have D, I just need to multiply one by the other. Not multiply, sorry. Divide one by the other. When I have D in the scale, I also divide one by the other. When I have the scale and the distance in centimeters on the ground, I multiply. In other words, within this relationship here, this pyramid, if I have one from the top and one from the bottom, I divide. And if I have both from the bottom, I multiply. Want to see how this works? Look, let's do the first proportion problem. So, what's the scale here? 1 to 250,000. If 1 is worth 250,000, how much will 9 be worth X? I don't know. I just need to do the multiplication. So X will be equal to 9 times 250,000. How much is that? I don't know. I'm going to do it here on the calculator because I'm not dumb, right? I don't need to take the college entrance exam, so I don't have to know how to do this by hand. You guys do. So, check this out. 250, 123 times 9. It's going to be equal to 2,250,000, okay? So I found the distance. I found it.
2.250.000.
1, 2, 3, 250,000. That's the distance in centimeters. But do I need to find the distance in centimeters? No, I have to convert it to kilometers. To convert to kilometers, what do? I move the decimal point 5 places to the left. So 1, 2, 3, 4, 5. I'll have the distance here, which is 22.5 kilometers. Okay, what's the answer? B, 22.5. Here, according to the rule I explained earlier, what do I have? I have the scale, right? Which the exercise gave me, and I have the distance in centimeters. So what do? I just multiply one by the other. Basically, I can shortcut all of this with the rule of 3, see? Okay, just by multiplying 250 by 9, I would get the same result. Did you get it? So let's move on to the next one. All right then. Again, if you want to do this exercise and check if you got it right, pause the video, okay? Let's go. Considering that the actual distance between Yokohama and Fukushima, two important locations where the 2020 Summer Olympics will be held, is 270 kilometers on a map with a scale of 1 to 1.5 million, this distance would be d. Okay, so notice here, what quantities do I have? I have the actual distance in kilometers, right? So I have the big D. How much is the big D here? 270 kilometers, right? And I also have the scale. What is the scale here? 1.5 million, 1 to 1.5 million. Oh, 1.5 million.
It's
1.5 million what? Centimeters. Notice that I have both values here. Big D in the scale, and he wants me to find little d, which is the distance in centimeters on the map. However, the two values I have here are in different units. I have kilometers and centimeters, so I have to convert from kilometers to centimeters, right? I can also convert this one from centimeters directly to kilometers, but either way, it will give the same result. Look, to convert from kilometers to centimeters, I just need to add 5 zeros, okay? So I add them here. 1, 2, 3, 4, 5. What number is this? 27 million, okay? In centimeters. Now I can go ahead and do the calculation. But look, remember what I said in the previous exercise? If I have the big D in the scale, what do I need to do? Divide one by the other. Again, I'm going to open my calculator here, okay? Check this out. 27, 1, 2, 3, 1, 2, 3. 27 million divided by 1,500,000 is equal to 18. 18.
18.
18 what? Centimeters. That is the distance on the map in centimeters. If I take my ruler and measure, it will be 18 centimeters. See how using this little rule here makes everything easier? So now let's go to the fourth and final exercise, okay? Stay strong. All right, let's go to our fourth and final exercise. Congratulations to you, warrior, who made it this far, okay? Stay strong. Take a look. Graphic scale according to Vicentini and Vlet. Oh, right, that's the one shown graphically. That part of the statement doesn't matter to us. Don't forget, in the entrance exam, we have to save time. In this sense, considering that the scale of a map is represented as... So, here I already have the scale. He gave me the scale. And that two cities, A and B, on this map are 5 centimeters apart from each other. The real distance between these cities is... So, what values did he give me here? He gave me the scale, right? Which is 1 to 25,000. Look at that. Scale 1 to 25,000. 1, 2, 3. And the little d, which is the distance in centimeters, he also gave me, which is 5 centimeters, okay? Scale in centimeters, little 10 also in centimeters. You just need to do the calculation. So what does he want me to find? The big D. Don't forget the rule. I have the scale and the little d, so I just need to multiply them. So look at this. 25,000 times 5, how much is that? Let me get my calculator. No, just kidding. I can do this calculation. 25, 50, 75, 100, 125. So, 125,000. What? Centimeters. This is my big D. Look, the tenor is 1 to 20. The tenor then is 125,000 centimeters in real life, okay? But notice how the options here are given, right? In meters, okay? Remember what I said? Sometimes it's more common to ask in kilometers, but sometimes they ask in meters. So I need to know how to do that too. From centimeters to meters, there's a difference of 2 decimal places, right? So you just move the decimal point 2 places to the left. So 1, 2. So we end up with 1 for make and 5, 0. What number is this?
1200
1,250. That's in meters, right? So the actual distance between city A and B is 1,250 meters, okay? See, it's not even that complicated. If you memorize this conversion rule and also remember this relationship here, big D, little d in scale, if I have the big 10 and the little 10, I divide. Big 10 in scale, I divide. Scale and little 10, I multiply. You'll be able to solve any exercise, all right? Oh, don't forget that we have our mind maps and slides ready for you if you want to make your classes easier, if you're a teacher, or your studies if you're a student. Check them out, okay? The links are here in the video description. I hope I was able to help you. Thanks to you who stayed until the end. Please leave a comment and like if I helped or you got the exercises right. That means a lot to me. See you next time. Take care and all the best.